I want you to interpret each one of these functions. That first function, the negative x plus 1, that's a what? What's it going to look like on your graph? Linear. This is the line. Okay, let's look at the second one, 2. What's that going to look like? What kind of straight line? Horizontal. Very good. And what about our x squared? Parabola. Okay, so we're going to have little bits and pieces of all three of those. So how I want you to think of this is I want you to think of these three functions as rules. I want you to think of them as rules. Okay. So if we look at our first linear function, I want you to look what they say here. They say if x is greater than or equal to negative 1, but less than 1. Okay? What are they telling you there? They're saying you're going to graph this line, but guess what? You're only going to graph the points that lie in here. Okay? So it's just going to be a very small part of your line. Because from negative 1 to 1, you really only have one number in between those, and that's what? 0. So it's not going to be a very long line, right? It's very, very, very tiny. And if we go to the next one, our f of x equal to 2, wow. They've really limited us to just what? No, the 2. If x equals what? 1. Talk about being limited, right? That's only going to be what, a point? And then look at your last one. What are they limiting us to? X is what? Greater than 1. So we're limited on one end, but the other end is what? Unlimited infinity. Okay, so we're going to start off with finding f of 0, f of 1, and f of 2. To find f of 0, you're going to have to come up to your rules and your intervals. And where does the 0 fall in your intervals, in your restrictions? Yeah, it's in between this. It's in between the negative 1 and the 1. Your 0's right there, okay? So the rule we're going to use is the negative x. The rule we're going to use is the f of x equals negative x plus 1. So f of 0 equal to the negative, instead of the x, put in the 0 plus 1. And what would that give you? It's going to be 1. So, and we can think of that as an ordered pair, 0, 1. Okay, so that's your f of 0. Now let's do the f of 1. Which rule are you going to have to follow for that one? The 2. So if f of 1, if x is 1, what's your output? You don't have a choice. It's just what? What's the output? What's the rule? The 2, yeah, it's just the 2. Yeah. So there's your point, right? Your input of 1 and your output of 2. So there's your point. And our last one, our f of 2. Which rule are you going to use? The x squared, right? Because that's greater than 1. Very good. So 2 squared, 4. So 2 gave us a 4. Okay. So let's talk, first of all, about the overall domain. The overall domain. Do we have a lower limit for our domain? Yes. What's the lowest x value that we can have? Negative 1 is the lowest value. And what's the highest value? Infinity. Yeah, infinity. Okay. So for our domain, let's say, are we including the negative 1? Yes. So we'll use a bracket. So we're going to go from negative 1 to positive infinity. And remember, interval notation, remember your infinities are always parentheses. Okay, let's graph this thing. We'll graph it by hand, and then I'll show you what it looks like at the way they did it. Okay. We're going to start with our line of negative x plus 1. So that's a y-intercept of 1. Are we going to include the 1? Is the 1 included? No. Does it have an equal to the 1? No. So we're going to make that an open point, right? So that'll be an open point, our y-intercept at 1. So let's do 1. Okay, so negative 1 would be 2 right here. Are we going to include him? Is he included? Open or closed endpoint? Open or closed endpoint? Look at your what's it called? Inequality. Your inequality, does it, for the negative 1, does it have the equal with it? Right here, does it have the equal? Yes. So open or closed endpoint? Closed. Okay, close it. Okay, connect them. Oh, yep. Let me redo. Do a better job than me. Oh, well. And that's it. So that's the interval between negative 1 and 1. No, wait. No, we need to go to 1. Keep going. So we're going to, yeah, I messed that up. Okay, so I'm going to take away that. Hold on. We're going to go make 1 be the open one. So we'll go through this one. So we'll do this. There we go. I knew I'd mess that up. Okay. So that's our first one. So we have the closed endpoint. We have the closed endpoint at negative 1, the open endpoint at 1, and our y-intercept. Okay, now let's do the 2. So we're really restricted when x equals 1, y equals 2. So you're just going to have that, and that's going to be closed. And that's all we can do with that one. Right? That's all we can do. I know, it looks funny, right? Okay, let's do our last one. X squared if x is greater than 1. We already found one of those points. We found 2, 4, so let's graph that. So 2, 4. So kind of about right there. Okay, so we know we have a parabola. We can only graph this thing from 1, which is right here. So he's going to be doing something like this, right? What do parabolas do? What do parabolas do? What am I going to put here at the end? There. Okay, and there it is. Okay, so here's what it looks like when it's graphed nicely. So you guys, look right here. Look right here. So here's the open endpoint and here's the closed endpoint. You see how they're kind of doing the parabola? They just kind of dashed it in. This part doesn't exist, right? Because you only wanted the values that were greater than 1. So that's why we just tailed them up this way. See that? So piece. So we have this little piece. We have that. There's our 1, 2, and then our parabola. Okay.